A malicious MCP server can steal your SSH keys without ever writing out one complete malicious instruction. The Asset Research Group just proved it. When the theft order is given in one block, the big models almost all refuse. But split that same order into harmless-looking fragments, and GPT-4o, Gemini 2.0 Flash, and Llama 3.3 comply in 100% of the tested cases. And while that's happening, you're probably adding a new MCP server to your agent every week, copying a config line you found on GitHub. Each of those servers holds a piece of your access: API tokens, cloud keys, service accounts. MCP is useful, nobody argues with that. But your MCP server has become the weakest link in your whole agent stack. If you're new here, this is AI Dive, where we stay on top of AI so you can stay on your work. And in this video, we're going over how an MCP server leaks your secrets without getting noticed, the GhostSplice attack that beats model refusals by splitting its instructions, and the concrete defenses, from Cloudflare WriteGuard to the rules we run on our own setup. If you already know exactly what an MCP server holds, skip ahead to the next chapter. For everyone else, this recap matters, because the danger comes straight from here. An MCP server is basically the bridge between your agent and an outside tool, your database, your GitHub, your Slack, your cloud. And to do that bridge work, it stores whatever it needs to log in as you: tokens, API keys, service account credentials. In plain text, in a config file on your disk, usually with zero encryption. Now, one protocol detail to keep in mind for later: when your agent connects to an MCP server, the server sends back its list of tools, each with a free text description telling the model when and how to use it. Those descriptions go straight into the model's context, with the same weight as your own instructions, and the results the tools return go in there too. So an MCP server basically talks to your agent non-stop, in text nobody ever rereads. Hold on to that, it's exactly what makes the GhostSplice attack possible. And the ecosystem blew up faster than its guardrails. The official MCP registry is past 9,600 published servers, and remote server deployments have grown 5 times over since May 2025. Anyone can publish a server, there's no central review, and your agent trusts it exactly like an official tool. The NSA itself published a security guide dedicated to MCP back in May, saying the protocol's adoption outpaced the building of its protections. And when an intelligence agency writes a guide about your favorite dev tool, it's rarely to congratulate you. So that's the setting. Thousands of servers, no review, and your keys in the middle. The first hole in the hull is credentials stored in plain text. The Hacker News published a detailed breakdown of the leak mechanics on August 17th, and the starting point is blunt. Tokens get pasted straight into configuration strings and stay readable on disk, so one slightly rushed commit is enough to push your config into a Git repo with the keys inside. And it gets worse with what the article calls sprawl, the same keys duplicated across config files, environment variables, and copies in dev, staging, and production. After a while, nobody knows where the secrets live, so nobody rotates them. A static key that never rotates is a key waiting for its attacker. The second hole is over-permissioning. During development, you hand your server broad rights to dodge authorization errors, and those broad rights ship to production untouched. So one single compromise exposes far more than real usage ever justified. And the third hole is even more direct: the supply chain. CVE 2025-6514 hit MCP remote, an OAuth proxy downloaded more than 400,000 times, and let a malicious server trigger command injection on your machine so it could run code and walk away with your credentials. One popular NPM package installed in one line, and the door was open. Now the fourth hole is the sneakiest one: prompt injection. Your agent reads everything its tools bring back: a web page, a ticket, an internal document. And if one of those contains a hidden instruction, the agent can follow it as if it came from you and use its legitimate tools to expose what it was supposed to protect. That leak doesn't go through any technical flaw, it goes through the model's gullibility. So before any sophisticated attack, the ordinary life of an MCP server, plain text config, oversized writes, unvetted dependencies, unfiltered content, already exposes your secrets. Now for the case that made everyone react this week. GhostSplice is the name the asset group gave to a technique that makes your own agent run the exfiltration with its full cooperation. The principle fits in one sentence. Instead of writing the theft order in full, the malicious server splits it up, puts one fragment in a tool's description and the other in the result that tool returns. Each piece, read alone, looks harmless, but the agent combines everything that enters its working context. It rebuilds the full instruction and executes it in complete good faith. From its point of view, it's just filling in the form the tool asked it to fill in. And the test numbers are the real story here. With the instruction given in one block, GPT-4o, Gemini 2.0 Flash, and Llama 3.3 refuse 100% of the time. With the fragmented version, all three comply 100% of the time. The Claude models hold up better on paper, but the detail kills the conclusion. Claude Haiku 4.5 refuses everything through the API, then gives in 100% of the time in the 3-piece test run inside Cursor. So the same model can refuse in one client and exfiltrate in another, depending on the protections the client adds or doesn't. What GhostSplice steals in the tests: SSH keys, environment secrets, source code, customer data. The researchers worked on isolated projects with fake keys, not on real victims, but the method is published and reproducible. And GhostSplice isn't a first try. The same lab published GhostCommit in June, an attack that hid its instructions in PNG files referenced by project conventions, then encoded the stolen secrets into source code as integers. So instruction splitting is a family of attacks settling in, not an isolated curiosity. 2 things to keep a cool head though. The attack has 2 prerequisites. You already plugged the malicious server into your agent, and the agent has read access to the target files. And that's exactly why provenance matters so much. Where your servers come from is your first line of defense. So remember the mechanics. The model's alignment doesn't protect you, because the attack never asks for anything forbidden in one piece. Quick pause. If AI Dive keeps you ahead of AI, subscribe and hit the bell so the next dive lands in your feed. GhostSplice assumed a malicious server already plugged in. But who decides what gets plugged in exactly? In a team, the honest answer is nobody. That's the problem Cloudflare calls shadow MCP, all those servers that devs connect to their agents without any security review. And until recently, that traffic was invisible. An MCP request looks like any other HTTPS call. Cloudflare just changed that with detection at the protocol level. Since the spec update, every conforming MCP client sends an MCP protocol version header on its requests, and Gateway inspects that header on all the TLS traffic it decrypts. Concretely, a security team can now see every MCP server used in the company with a dedicated dashboard, unique servers, users, request volumes. And this header approach beats filtering by domain name, because an MCP server has no reason to call itself MCP something. The protocol gets spotted by what it says, not by what it claims to be. And above all, the team can act, and is MCP selector lets you block any MCP traffic that didn't come through an approved portal. The portal is the other half of the setup. One single access point that groups the vetted servers behind identity authentication. Now the latest spec version pushes visibility even further. The new MCP method and MCP name headers expose the requested operation and the tool being called, without the firewall having to open the request body. So a team can tell an agent reading a ticket from an agent deleting 50 of them, right at the network level. Cloudflare actually splits this into 2 cases. Pure shadow MCP, a server that was never approved, and portal bypass, an approved server reached directly around the checkpoint. Both get blocked with the same base rule. So the logic is simple. Everything through the portal is known and logged. Everything else is blocked. For a company, that's the end of the Ghost MCP server installed on a Friday night. That still leaves the thinnest problem. Even an approved server can do damage because your agent inherits every one of your writes at once. And that's where WriteGuard comes in, which Cloudflare just opened in private beta. The idea? Classify every tool of every MCP server into a risk tier and apply a different policy per tier. A read passes with no friction. A contained write, like posting a comment, passes but enriched. The action is signed as coming from an agent on behalf of a specific human, and an audit event goes to a central log. And a critical action, merging code, deploying to production, mass deleting, is blocked before the server even handles it. The GitLab example in the post shows the gradation well. Reading a merge request passes, commenting on it passes with attribution, and merging it is refused until a human does it themselves. The most interesting part is the identity model. The agent keeps the permissions of the employee it serves, but every write now carries 2 signatures, the person and the agent session acting for them. So downstream systems can finally tell a handmade change from a machine-generated one, and the audit ships asynchronously to a central log scrubbed of sensitive data. Until now, an agent was indistinguishable from its human in the logs, and for an incident audit that changes everything. One query tells you whether Tuesday's dubious merge came from a hurried coworker or an agent session that got creative. And Cloudflare isn't selling a theory, they describe their own internal use. Their portal connects 27 MCP servers, up from 13 in April. That number tells the real story. Even at their place, the server count doubles in a few months, and that's exactly why per-tool control becomes necessary. So the direction the industry is taking is clear. We stop trusting the whole server, and we decide action by action what an agent is allowed to do. Now, there's a limit to all of this, and it needs saying plainly. WriteGuard is a private beta behind a sign-up form, and Gateway's detection needs a Cloudflare Zero Trust deployment with TLS inspection turned on. If you're a solo dev or a small team, that's simply not your infrastructure. And even in a company, the detection only sees the network traffic, it decrypts. A local MCP server running over STDO, launched as a plain process on your machine, stays invisible to gateway, which is exactly how most of the servers devs install actually run. Above all, none of these tools repairs the core mechanic GhostSplice exposed. As long as an agent freely combines whatever enters its context, harmless fragments will keep recomposing into hostile instructions. The asset researchers say it themselves. The fix requires treating tool output as data, never as instructions, and that separation doesn't exist natively in agents yet. In the meantime, their recommendations come down to 3 moves. Stop values coming out of one tool from feeding another tool's arguments unchecked, keep the ability to deny each tool invocation by hand, and treat any annotation from an unvetted server as hostile by default. None of the 3 is automatic today. You apply them, or nobody does. So treat everything Cloudflare ships here as seatbelts, not brakes. It limits the damage, it doesn't prevent the collision. So what would we actually do starting today? First, the inventory. List the MCP servers really plugged into your agents, and remove the ones you no longer use. Then sort by provenance. An official server from a known vendor, yes. A 40-star GitHub repo found in a thread, no, not until you've read what it does with your data. Then the rights. Give each server a dedicated token with the minimal scope, never your master key, and rotate those tokens like you would for any production system. And keep your hand on the sensitive actions. An agent that writes, merges, or deletes has to come back through you, which is basically the handmade version of what WriteGuard industrializes. And apply the GhostSplice rule day to day. When your agent chains tool actions you didn't ask for, stop it and read what the server has been telling it. Every agent client can list its connected servers and their tools, and that list takes 30 seconds to read. Those 30 seconds are the best time to security ratio in your whole setup. If you're at a company, add the network layer. Gateways, MCP detection, and the portals are worth the rollout, because Shadow MCP already exists in your org, whether you see it or not. MCP isn't the problem. The speed at which we handed it our keys is. That's the dive. If this earned a minute of your day, the super thanks button below keeps them coming. Subscribe and hit the bell so the next one reaches you. See you in the next one.